hope you still want me. I hope you still need me 1,000,000 years from now. The seasons are changing, the nights ever fading. It's time we left the ground. Let's leave for an eternity. Sail across the lights beyond the sky. I'll be with you eternally. Addict for your love that keeps me high. Keeps me high. Can I be your star tonight? You fill my soul with light the day we met. I don't wanna leave your side, no. Have me by your side when the sun sets. Let's leave for an eternity. We'll sail across the lights beyond the sky. I'll be with you eternally. I'm an addict for your love that keeps me high.
Hello, 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 everybody. How's everybody doing today? How's everybody doing this evening for our 6 o'clock Math 102 class? I hope everybody is fantastic. Hope we're doing well here today. We'll get started in a few minutes. Wait for people to trickle on in. Hopefully you've finished up your homework and tests. Forget that's due today, actually. It's due today at 11:59 p.m. Don't forget about that. Kind of a thing. That's fine, I guess. All right. All right. Good to see everybody here today. Good to see everyone. Good to see everybody today. All right. Okay. All right. Okay. All right. We'll get started here in just a few minutes, folks. We will get started in just a few minutes. Again, if you're out there, just wait on a few more people to come on in, and we'll get going, just as usual. Anybody got any plans for the weekend? I don't know if you guys got plans or not. Work? Ellie, were you able to at least finish up the homework and test stuff? Hopefully, hopefully hopefully that won't interfere with you going to work tomorrow or the weekend. Hopefully you got everything. Almost done? Okay. Did you do the test at least? Because that's due at, 11:59 tonight. So, I hope you have at least that part done. You can get the little bits of scraps of homework done pretty quick then. All right, give me about another minute or two, and we'll go ahead and get going here. Hopefully we have that test done. It's kind of important, just a smidge. Hey, Maritza, how are you doing? Is it bad if I did like 3 practice tests? No. You could take the practice test as much as you wanted to, so nothing wrong with that. Did you get a good score on the actual test? If you did do a few practice tests, hopefully that the real test went out pretty well. It's not bad at all, David. Not bad at all, my man. As long as at the end of the day it helped you. Yeah. And the 3 practice tests helped them in a lot, right? I hope they helped a lot. Sometimes it just takes more than one try. That's fine. Yeah. There you go. No judgments, my friend. That's exactly what the practice test is designed to do. So, there's no judgments here. I'm glad you put forth a lot of effort and you got the score that you were looking for. That's exactly why it's there. So good job, David. That's what I'm talking about. Give yourself enough practice, give yourself enough time, and it works out really well. Wait until the last minute. It usually doesn't work out very well. Usually 10 times out of 10, it doesn't work out very well if you procrastinate until the last minute. Very nice. Very nicely done. Very nicely done. All right. I think we are ready to get started with stuff here today for say next section. So let's go ahead. Just the last part of putting all the numbers in the calculator stressed me out. That's fair. That's fair. But if you follow the directions there carefully, it seemed like you did a great job in getting that process down. Maybe you watched a couple of the replays of the videos a few times and you're able to get comfortable with that. So that's good to see. To be clear, you'll take the best of 3 tests. To be clear, I'll just take the best one. If you tried it 3 times there, Horace, I think I gave five tries instead of 3. But whatever the best out of the 5 is gonna be, then that's the best. I always take the best score, no matter if you don't do as well the other times. Let's say you got a 95 the first test, and you're trying to get 100, you don't get 100, you get below 95, I still take the 95. So Always the best score wins. That's how it goes. That will always be the rule. All right. Let's go ahead and get started. Let's do some intros, and we need to talk about a couple things. So let's do that. Okay, let's get started today. Welcome back to Thursday, end of the week time today. All right, so for today, we're going to continue moving on here in Chapter 4. We're going to do Section 5.4. That's what's on the docket here next. Hortz, have you done the actual test? I hope you've done the actual test, as that's due at 11:59 tonight. So be sure to finish that if you haven't. Be sure to save and finish that before 11:59 tonight. So you can get the credit for the test there. Well, I hope you... The multiple practice test, that's good. But yeah, please, Hortz, I want you to get a grade. Practice tests won't count as actual grade, and you'll need to actually do the test. Remember that the actual test doesn't come with the help me solve this or view an example. Be sure you know your stuff there. After we're done here, straight to the test. Otherwise, yeah, I don't want you to get a 0. Now, speaking of the exam, though, there is one more thing I need to speak about the exam here. For those of you who have done it or have not done it, regardless, what I have done effectively here for the test is somebody brought it to my attention that one of the questions on the exam was a problem that we did not cover in the class, and that was stuff to do with standard deviation of group data and the mean of group data. Now, we did not actually cover that topic here in class. I did in my other class, which is 120, which is another stats class, but we did not do it here in this class, which is 102. So what I did was, because, again, my policy is that I don't give questions for problems that we do not cover. Any sections we don't cover, there should be no questions about that. I went ahead and removed that question off of the test. So from 30 questions, there should be 29 questions. Okay, so, and you should get credit for that particular question. So just letting you know now, I went ahead and removed that question, and you'll get credit for all the other questions. It's just, again, I removed that one because, again, I want to keep the system as fair as possible. Okay, so just wanted to let you know, there'll be 29 instead of 30, but there you go. Not too bad. All right. And your score will be adjusted appropriately, by the way, so don't worry about that. Your score will be adjusted to the positive, by the way, to the positive. Your score will be adjusted positively. So I will certainly make adjustments as necessary when I record that in the grade book. Okay. All right. So I just wanted to make that announcement here really quick before we went ahead and got started with today. Let's go to the big board though, and let's start talking about what we need to do here today in section 5.4. All right, let us take a look here. Actually, before I do that, are there any questions about that? Hopefully everybody's good with that. Any questions? No? Okay. All right. So, today, let's take a look at Section 5.4. Section 5.4, we're going to be continuing on with probabilities. Last time, we talked about probabilities where we used the general addition rule and the general multiplication rule. 5.2, 5.3 was general multiplication rule. We said, okay, to find the probability of A and B if they're independent events. And we said, okay, you take the probability of A, multiply by the probability of B if they are separate from each other. Now, today, we're going to be doing what's called conditional probabilities. Now, these conditional probabilities are what happens if we have two events that are not independent of each other. So one does rely on the other. Okay, that is where conditional probabilities or other types of probabilities we'll also see using the general multiplication rule and also including with or without replacement. So what happens to probabilities if they are dependent on each other in some form or fashion? So that is what we are going to be looking at here today. So let's talk about what conditional probability is and what the key difference is between what we talked about here last time and what you're going to see here in this section. what is conditional probability and what is its notation? So first of all, the formal definition here of conditional probability is the probability of one event B given that an event has occurred. So essentially, I'm given a condition here that already exists. In this case, we're going to call it event A. Event A is going to be, again, the condition that already exists. Now, within that context of event A already given or occurring, what's the probability that another event B is going to occur? So that's essentially what you're trying to find. We're trying to find a probability within a smaller box, if you want to call it that. So instead of looking at the big box here, we're now looking at a smaller box and looking at the probability inside that smaller box. It's another way to kind of state that from a picture perspective. Okay, so what's the best way to kind of get to know how this works? Well, let's take a look at the notation here. The notation here says, if we read this properly here, it says the probability of B, there's a line here, and A. This is the probability of B given A. Okay, so the probability of B given, again, that's what this line here represents, A. And what is important here to note is we do want to read this probability here specifically from left to right. Now, you're probably saying, it seems kind of strange. Why would you say that reading it left to right would matter here? Well, if I read it from left to right, the probability of B given A, what is going to significantly matter is how we actually do the calculations. What that means is that order of the letters, or order of whatever B and A represents, it is going to significantly matter and impact the probability of what we find at the end of the problem, depending on the context. So again, how it's written is actually very, very important in determining what numbers we need to use to figure out what probability we're going to find. Now let's talk about the numbers here, at least what number goes where. That's a little bit more important here in our practical examples. So let's look at number 4. So from a kind of a abstract perspective here, how do we compute conditional probability? So the probability of B given A is equal to the probability of A and B divided by the probability of A. Or, in other words, the number of A and B divided by the number of A. You're probably saying that looks, yeah. Not gonna lie, with letters. Again, I put this in both letters and actual words. So again, I have letters and words here, just appropriate. One thing to recognize here is that because order matters here, that's why I put here note number 2, order matters. The probability of B given A is not the same as the probability of A given B. They are two separate probabilities. They are never going to be equal. That's, again, it just depends from situation to situation. Is determinant if they're going to be equal or not. So they're two separate probabilities. You should treat it as two separate problems. Okay. Now this is all well and good in terms of an abstract. Now that's fine. But we need to look at an actual practical example here. So having this is nice, but practical examples are a little bit more important. Let's go ahead and see a practical example here. I'm going to look at the textbook here in order to. Okay. So the number that we're going to do here is going to be number 17. All right. All right. Let's go ahead and read this off here, and let's look at number 17. All right. So this is should be a familiar problem. We did look at this one a little while ago. That's okay if you don't remember. So let's look here. It says made in America. Okay, so in a recent Harris poll, a random sample of adult Americans 18 years and older was asked, when you see an ad emphasizing that a product is made in America, are you more likely to buy it, less likely to buy it, or neither more nor less likely to buy it? So here's the age groups, and here are the, again, the categories of more, less, or neither, okay, and their respective totals. All right, we're going to go down the line here. The questions here for this guy is on the next page, but I'm just going to read it off here off of my book. So let's go ahead and do it. What is the probability that a randomly selected individual is 35 to 44 years of age, given that the individual is more likely to buy a product emphasized made in America. Okay. So probability that you're in 35 to 44, given that you're more likely to buy. Okay. Now, in this particular case, how would we go about finding this particular probability? We are going to use that little formula that we had on the handout here. Let me show you a little bit of an easier way. It looks, again, on paper, with the words and stuff, it can be a little confusing. But let's look at it through the context of this problem here. I'll show you how it works. Now, if we read from left to right here, we say the probability of 35 to 44 given that they're more likely to buy. So I'm looking at the first condition here. Let me look at the condition here. The condition here is that I'm more likely to buy. So I need to find the people who say the number of people who said more. Okay, so the number of more. And then on top, I need to find out, well, within that more amount of people, how many of them are 35 to 44? Essentially, the number of 35 to 44 and more. Okay, let's look at this here. Okay, so let's answer some questions here. You guys can help me out with this. All right. So, taking a look at the table off to the left, how many people are in the more category? What's the number of people who are more in this table, more likely to buy items? How many people are more likely to buy items? Go ahead and post that in the chat here. So again, based on this table we have here off to the left, how many people are more likely to buy? Okay, so 1329 here is what we get. Okay, very good. All right. That looks good to me. So according to the table here, we have 1,329 people total who said that they're more likely to buy. Now, here's the big key question here. Found out how many people are in the more category, but let's answer this question here. Of those 1,329 people, how many of them are between the ages of 35 to 44? So out of the 1,329, how many of them are between the ages of 35 to 44, according to the table? $329. Okay, that is correct. So now we've found our probability here, right? We have 329 divided by 1329. Okay. And now just bit bop boop that on the calculator there. What do we get as a decimal here? Get 329 divided by 1329. What's that going to be? What do we get here? Anybody got a decimal for me? 4 decimal places, guys. 2476. All right. Good. Excellent, excellent, excellent. All right. So far, so good. All right. So before we move forward here, are there any questions? Any questions about that? Any questions? No? Okay. Want to be sure everybody's on the same page here. All right. All right. Is there a reason why you started the number 0? You mean 0.2476? Is that what you mean? I'm a little confused what you mean by that. You have to be a little more clear with your question here. This is sorry. This is the number of. This is what it says. The number of. I know that looks a little weird. That's okay. I meant to put it. I know that looks a little strange. Put of right here. All right. All right. Let's look at letter B here. Letter B says, what is the probability that a randomly selected individual is more likely to buy a product emphasized made in America given the individual is 35 to 44? So in this case here, we're reversing stuff around. So now we're taking the probability of or given that we're 35 to 44. All right? Seems fair. All right? So let's go ahead and figure this out here. First and foremost, let's go through this here a little bit together. How many people are 35 to 44? So according to the table here, how many people are 35 to 44? All right. So we have 536 people. All right, that sounds good to me. 536. Now, of those 536 people, how many of them are more likely? All right. 329. So here's 536. Look in this column here. 329 are more likely to say, I want to buy more stuff made in America. Fine. Okay, so we're just going to divide these two guys here together. 329 divided by 536. And what's our decimal equivalent here in this case? $6,138. Okay, good. Okay, great. Nice. Okay, no problem. So far, so good. So far, so good. All right, now you notice here that when we did the probability of 35 to 44 given more, that was 2.2476. You see the probability of more given 35 to 44, so we just reverse things around. We got a completely different probability at the end of the day. Okay, just a completely different one, right? So there's again, they do not equal the same number here. If we reverse stuff around, order significantly matters. Okay, questions about that? Questions about that before we move on? Any quick questions or anything like that? Any questions? No? Okay. Just go ahead and move forward then. No problem. All right. Now this next example here that I'm going to come up with is going to be kind of my own example here. So this one's not in the book, but this is one that I'm going to come up with on my own. So let's go ahead and you guys put down your answer to this one here in the chat. All right. So how about the probability of 55 plus given neither? Probability of 55 plus given neither. All right, put your answers there in the chat. Put your answer as a fraction. All right, so we'll figure out the decimal portion after that, but put it as the fraction with the numbers. So what do you think? What should be the fractional equivalent of this probability here? What do you guys think? Give you, right? Got 118 over 765, all right? Let's see what other guesses that we have here. All right, 118 over 536, all right? Any other guesses here? Any other guesses here? Anna, Strolling, anyone? Sanla, Maritza, Oritz? Hmm. All right, Strolling put 402. Okay. 118 over 536, all right? Okay, let's take a good look here. All very, very good guesses. Let's take a look here. So we have the probability of 55 plus given the fact that we're neither. Now, let's look at neither here. How many people are neither? Well, according to our table here, the amount of people here that are neither, whatever you want to call it, is 765 people. Well, out of those 765 people, how many of them are 55 plus? Well, that's going to be 118 in that instance. So it would be 118 divided by 765. And so here in this case, we get 0.1542. So some of you put 765 here, and some of you put 536. 536 would be if I added up all the 55 pluses. But remember, order matters here. Our condition here is neither. So I said, okay, well, how many people in this category of neither first? Well, there's 765 people in that neither category. Well, how many of them are 55 plus? Okay, well, there's 118 people who are 55 plus in the neither category. All right. Seem we're a little off there, and that's fine. That's not a problem if you didn't get this right. I'm going to do a couple more examples for sure. Let's try another one, okay? Let's see if you guys can grab this one. All right, so how about this? The probability of more given 18 to 34. Okay, the probability of more given 18 to 34. What would that be here in this instance? Probability of more given 18 to 34. What do you guys think? The probability of more given 18 to 34. Go ahead and post your answers in the chat. Whatever guesses it may be, that's fine. Probability of more Given 18 to 34. Okay. Silent put 238 over 542. Let's see what other people come up with. See what other guesses we got. So if you got that strolling, tell me how you got that. What numbers did you use to divide in order to get that answer? So strolling, be a little careful here. Remember what's your given condition. Let me ask you this question here. Strolling, what's your given condition here? Is it more or is it 18 to 34? Be a little careful here. Remember how to read this, okay? So strolling, if you want to, read it out loud. Given is 18 to 34. So first focus on how many 18 to 34-year-olds you have. That's the number that should go on the bottom if that's your given condition. All right. Any more guesses? All right, let's take a good look. So that's exactly what I'm going to do here. I'm going to first focus on how many 18 to 34-year-olds that we have according to our table. According to our table, if we add up the number of 18 to 34-year-olds, that's going to be 542. How many of the 542 people are more likely? That's 238. Okay. So here, in fact, if I do the decimal equivalent here, I get 0.491. All right. Any questions about that? Any questions? Should we do one more example? No? Okay. And should we do one more example though? Everybody, or is everybody good? One more example or everybody's good? Yes? Okay. All right, let's do one more example from this table, okay? And then let's see if you guys get it, okay? So let's do this last example here from using this table. So how about the probability of, let's see, let's see here, 35 to 44. Actually, no, I'm going to put it this way. Yeah, we'll do it. There we go. That's a bit nicer. All right. So the probability of less given 35 to 44. The probability of less given 35 to 44. All right, so you guys put that down as a fraction in there. Probability of less given 35 to 44. Six over 536. All right. See what others have to say. 6 over 536. All right. See some of the same ones here. Okay, another 10 seconds or so. Down your final guesses here. Okay. Let's take a look here and see if we got the right answer. So we got to look at 35 to 44. How many people are 35 to 44? So the first and foremost here, the number of people at 35 to 44 is 536. How many people how many people of those 536? So that's the key difference here. How many people of those 536 people are less likely? Well, there's only 6. Only the 6. So 6 over 536 is correct here. And so we get 0.0112. Yeah, that's great. All right, any questions about this example? We'll move on after this, but any questions? All right. Okay. Let's move on to the next example then, for good. Okay, so we do need to answer the last 2 questions on our handout, so let's at least acknowledge those. Go back to the handout here for just a moment. All right, so what we've talked about here already a little bit is we've talked about the general multiplication rule. Now we're going to see this a little bit more in action, but maybe not as direct as what it's written up here. Now you could use a little bit of algebra, some simple algebra from the previous formula here for this rule for conditional probability, and you can find the probability of A and B if they're dependent on each other. Again, that's going to be the probability of A and B if they're dependent on each other, not independent. Meaning to say, again, probability A and B is equal to the probability of A times the probability of B given A. So if they are dependent on each other or not independent, then this is just another formula that you can use to go ahead and find out and do so. Now, the real way we kind of do this is we still want to use logic here in these problems to essentially find these respective probabilities, much the same way we did in the previous example when we did conditional probabilities using our table. All right. So what we're going to be looking at here is how do we look at and use this general multiplication rule in like a more logical manner? Well, it just depends on what situation that we're given here. So we could talk about sampling here with and without replacement. So essentially, let's talk about with replacement, without replacement. So essentially just take it, just take it exactly as it means. Imagine if I said I have a deck of cards, for example, and I ask you, hey, can you select one card out of the deck of cards? If you take one card, you look at it, maybe I'm doing some kind of magic trick, and I ask you, okay, put it back into the deck. Now, if you put that card back into the deck, that is with replacement. You're taking what you took out, and you're putting it back into, say, the bucket, or in our case, the deck of cards. Without replacement is if I asked you once again with those deck of cards, I asked you, could you take a card and keep it? So you take the card, you keep that card with you, and you do not put it back in the deck. So that is without replacement. Now, of course, because it depends on with or without replacement, that's going to, of course, affect our probability at the end of the day. We do need to be careful about, of course, other things that we may need to be careful about, of course, is at least or exactly probabilities must be done differently, as we looked about that before. But let's take a look at some examples here of some probabilities that'll hopefully be a little bit more direct. Let's see how it works out. All right. So what we're going to do here in this case, go ahead and do, this will be number 27. Okay, so this will be 27. In this book. Okay. All right. Let's go ahead and read this together here. and we'll see exactly how to do this problem out. All right. All right, so 27 says, suppose that a digital music player has 13 tracks. After listening to all the songs, you decide that you like 5 of them. All right, with the random feature on your player, each of the 13 songs is played once in random order. Find that the probability that among the first 2 songs played, you like both of them, would this be unusual? You like neither of them, like exactly one of them, and we're going to skip D here in this example. All right. So let's talk about the breakdown of, say, the CD or these tracks that we downloaded or whatever. It doesn't matter. It is what it is. All right. In any case, more importantly is that on the CD or whatever, there's going to be 13 songs. So there'll be 13 tracks. And then of these 13 tracks, there are going to be 5 that we like. So we listen to all the tracks. 5 of these tracks are things that we like. So we're like, okay, this song's pretty catchy. It's pretty banging. No problem. Now, here's a question for you all. If we like 5 songs on this CD, then how many do we not like? How many do we dislike? Answer that first. How many do we dislike if we like 5 songs? You scared me there, David. I was like, oh, wait, what? Woo! Alright, so if we like 5 songs out of the 13 tracks, then there's going to be 8 songs that we dislike, okay? We don't really want to listen to them. They're not very good, okay? So, not every song is a banger, but we like those songs in particular, okay? So we have 5 that we like and 8 that we dislike, right? Good stuff. Alright, so this will prove to be important here. Let's take a good look here at letter A. We want the probability that we like both songs, okay? If we like both songs, that's fine. So let's look at it from, again, a picture perspective here. Here we have the first song. We have the second song. Okay. Now here's the way it's going to work here for this player. One of the most important parts here in this problem is that we have each song has to be played once in random order before it reshuffles back and plays the first one that it had. So essentially, you have to play all 13 songs and then it'll loop back and play 13 songs again. Okay, so that's basically how it's going to go, again, in random order. So essentially, because this has to be played at least once, this is going to be, in this case, without replacement. Okay. Now, knowing that to be the case, let's look at the first song that pops up here. So the first song comes on, and it's a song that we like. Okay, what are the odds, or what is the probability, either way, that the first song that we listen to, it happens to be a song that we like? What's the probability that the first song that's played is a song that we like? I know you're from England, Beast. Buddy, I know I've known for quite a while. What kind of comment is that? I've I've known that for quite a while. Uh, Oh, I'm sorry, Beast. I thought you were from Minnesota. I'm terribly sorry. Like having a convo with my long lost uncle. 1 out of 13. So the first song that you play there, you have a 1 out of 13 chance of having the first song that you play is 1 out of 13. Think about it this way. All right. The probability of the first song played is a song you like. Not 1 out of 13. I will tell you that right now. Not 1 out of 13. Look carefully. 5 out of 13. That is correct. So there are 5 songs in the pool out of the 13 songs overall that we like. All right, so we're going to put 5 out of 13. I'm from England. No, I'm Minnesota. That's where you're from. No, I'm just All right, very good. All right, so 5 out of 13, fine. Now, the next song has to play. Next song plays, and that's another song that we like. Remember that we're doing this without replacement. So once that first song is played, it won't come back until all the other songs have been played. So, what's the probability that we have the second song being the song that you like? What is that going to be? Probability of the second song is a song that you like. And think about it carefully here. 5 out of 12, that's close, David. That's close. Again, there are 12 songs left in the pool, so I'm going to definitely agree with you there. There are 12 songs left in the pool. True. Ah, very good. The answer is 4 out of 12, right? We've already listened to one song that we liked. So that's great. Okay, we had a good time listening to that song. So that song's over. Next song comes on. And now we have 4 songs left in the pool that we like out of the 5, out of the total of 12 songs that it can select. Because, again, going without replacement. So now we have 5 out of 13 times 4 out of 12. All right, so 5 out of 13 times 4 out of 12. So if we went ahead and did that here, get point 1282. Okay, we multiply those, that's what we get there. Perfect. Nicely done. All right. Any questions about that first part there? Hopefully that isn't too confusing. Any questions? Any questions so far? Go on, move to the next part here. None? Okay, so hopefully it makes a bit of sense. I'm going to follow the same kind of idea for the next one, okay? Let's try it this one here. Letter B, the probability that we like neither of them. The probability that we like neither. So let's at least met it out here. We have the first song and we have the second song. Again, we dislike the first song, dislike the second song. So can anybody tell me what's the probability that we dislike the first song? What's the probability that we dislike the first song? 8 out of 13 is correct. Good. That is right. Nice. All right, so pretty easy, right? There's 8 songs out of the 13 that we just don't like. Thumbs up. Well, too bad, so sad. We're just gonna sit there in a lull until the next one comes on. All right, first song's over, fine. Next song pops up, and once again, it's yet another song that we dislike. What's the probability that that second song is a song we dislike? Good, 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 good. 7 out of 12. That's correct. Very nicely done, everybody. All right, so we remove one song from the pool. That'd be 12 overall. And we remove one song from the dislike pile since we already listened to one. And that means we have 7 left. All right, so we multiply these two together. And we're going to end up with an answer here. Anybody have an answer for me, decimal-wise? Decimal, what's our decimal answer?
I'm hopeless in the crossfire. There's nowhere to go.
3560.
My desires, my heart overflows.
Okay.
The only direction
All right, there we go. Easy peasy. All right, no problem. Okay, so that's letter B. At 3590, uh-oh, like we got discrepancies. 2590, okay, looks like we got lots of discrepancies. Let's go ahead and figure this out. I don't know what you're entering in anymore. Now I need to see for myself. All right, let's see. 3590. Okay, let's change that up. There we go. All right. Okay. All right, good. All right, there we go. All right. So letter C here is what happens if we exactly like one of them? How do you conclude that the problem is non-replacement? So I concluded that the problem is non-replacement because of something that was specifically written into this problem strolling. And that was actually this line right here. This line right here where it says, with the random feature on your player, each of the 13 songs is played once in random order. Because it's written that way, essentially that's telling us we have to play every song once, and then it'll shuffle back around and play the songs again, probably in that order once again, more than likely. The old shuffler and the old CD players used to never be random, truly random. So that's essentially how we can conclude it's non-replacement, because we don't replay that song again because of that line. Like if it was truly, truly random, then yes, the song can repeat. But in this case here, we're forced underneath the condition for each song to be played at least once before it goes back to the start. All right, cool. Okay, let's look at letter C, the probability that we exactly like one of them. All right, so that means that now it doesn't matter which way you actually do this. You can have the first song be the song you like and the second song you dislike, or you can have the first song you dislike and the second song you like. Either way, you're going to end up with the same probability regardless. All right, so let's see how this works. All right, so let's say the first song here. Let's say you dislike the first song, but let's say the second song is a song that you like. All right, so this will be fine. Okay. So let's say we have the first song here, the first song we dislike. So what's the probability of the first song we dislike? What's that probability? Okay, so the first song selected is a song that we don't like. So that's going to be our standard 8 out of 13. Okay, so we have 13 songs and 8 of them we don't like. Just straight up an 8 out of 13, no problem. Okay, now we're not replacing anything still. This goes without replacement. So we do the second song here. What's the probability that the second song is randomly played and the second song is a song we like? What's that going to be? Second song is a song we like. Now I agree with the out of 12 part here. Remember, it's the second song we like here. So we like the song, so it's going to be 5, because there's 5 songs we like out of 12. So not 4 here, Strolling, because we haven't listened to a song we liked here yet. So it can't be 4 out of 12. The first song was a song we disliked. So we haven't used any songs from the pool of songs we like. There's still 5 songs that we like left in the pool. There is though one less song in the pool that we can select from here, the big pool. So we go down from 13 to 12 because of course it's the second song being played. But what is important is the number of songs that we like hasn't changed. That's why we're going to put a 5 out of 12 here in this instance. So one thing not just to make sure here, Strolling, is just to make sure that you're looking at each condition here carefully. Okay, that's why, again, probably having something like this will be fairly helpful, and just making sure you know what information you got. So you know exactly how many you have left over after each subsequent play of the song. All right, let's go ahead and got here. So 2, 5, 6. Okay, good. So that's how we can do number 27. Any questions so far? Got another example to do, but any questions? Okay. All right. Okay, let's go to here. All righty. So, the next problem that we're going to do here specifically is we're going to go ahead and do number 29. All right. So this will be our last example here for today. But 29, we're going to go ahead and do this here. And let's see how you guys end up doing here. All right. Now, a bag of 30 tulip bulbs purchased from a nursery contains 12 red tulip bulbs, 10 yellow tulip bulbs, and 8 purple tulip bulbs. All right. Now, in this case here, we're going to find some probabilities associated with that. All right. So let's go ahead and take a look here at this. All right. So we have 12 red. Again, let's just write down what we have here. We have 12 red, 10 yellow, and 8 purple. Now, one thing we're going to assume here in this case is, let's say, for example, in this particular question, we're going to do this with replacement, okay? So we're going to do this with replacement. So essentially, all I do is I reach into the bucket, I grab a tulip bulb, I make note of its color, and then I throw that tulip bulb back into the bucket with the other bulbs. And then I reach in and pull again, okay? So let's look at letter A. What's the probability that 2 randomly selected tulip bulbs are both red? All right, let's look at each one here. So the first one is red, and the second one is also red. All right, so Strolling says, so the first one here for red, Strolling says it's 12 out of 30. That's correct. So there's 12 out of 30 here for the first pull. Again, I reach into the bucket, I grab out a bulb, I look at it, I see that it's the color red, make a note of that, throw it back into the bucket. I reach into the bucket again, I grab a bulb, see once again it's red. Oh, but since we are doing this with replacement, then that is correct. We are going to have the same probability for the second pull here, which will be 12 out of 30. All right, feels fair. All right, we get 12 out of 30 times 12 out of 30. And what's that as a decimal here? As a decimal, what's that going to be? 0.16 is correct. Okay, good. All right, so not too bad. So far, so good. All right, now let's try the second probability. Again, with replacement still. So B, what is the probability that the first bulb selected is red and the second is yellow? We have red and yellow. All right, so we have red, and then the next pull here we get yellow. Okay, so the first one is red. That's going to be 12 out of 30. That's correct. And again, we take it out. We see that it's red. We throw it back into the bucket. And then we look at the yellow. Well, we have 10 yellows here, according to our problem. 10 yellows. So that's going to be 10 out of 30. Again, the amount doesn't change because we are replacing it after every pull. And what's our decimal equivalent here? 12 out of 30 times 10 out of 30. What's our decimal here? 0.1333. Okay. Again, be a little careful there, Anna. You want 4 decimal places. Remember, that's going to be our standard MO here, Anna. So 4 decimal places all the time. All right. Now, this time, let's change this up a little bit. Let's go without replacement here, and I'll ask my own question here with this same setup in terms of the bulbs with replacement. If I can. So let's say I wanted to find the probability of purple and yellow. This time, though, what's the key difference? The key difference is I'm doing without replacement. So again, I reach my hand into the bucket, I pull out a purple, and then I'm like, okay, I'm going to probably plant this purple tulip bulb. So I put that off to the side. I don't put it back in the bucket. I put it off to the side. I'm going to use this. Reach back into the bucket again, pull out another bulb, and this time I pull out a yellow, and I make note of that. And there you go. Those are my two pulls. All right, so I'm not going to replace this time here. I have purple and yellow. All right, so I have 8 out of 30 for the purple one. That is correct. Okay, good. Right, there's 8 purple bulbs out of the 30 bulbs in the bucket. But since we're not replacing, that's correct. 10 out of 29, right? We have to reduce 1 here because there's 1 less bulb in the bucket since we're putting it off to the side. And there's 10 yellow bulbs still left in the bag. Okay. And all we have to do from here is go ahead and multiply those two together. You can see these are pretty nice and simple. Hopefully, again, as you see, you guys have done really well with these. Took the first class a little bit of time, but... So we got 0.090. Okay. All right. Okay, so that's going to be our final answer for that particular problem. All right. And so that is going to be effectively the end of section 5.4. Are there any questions about that section? Any questions at all? Okay. Yeah, just study the section. That's fine. Take your time with this one, Strolling. All right, it's not a problem. Okay, good. All right, just switch to the big cam here. Okay, very good job here today, everybody. All right, excellent work. You guys did absolutely fantastic. All right, I want to thank everybody who came on out here to the stream once again. Again, if you haven't finished your homework or test yet, please be sure to get on that right away, right after we're done with the stream. That'll be due at 11:59 p.m. Remember that you do have to save your work before 11:59 p.m. in order for it to count. Okay, so if you save after 11:59, too bad, so sad. All right. So that is what I'm going to be doing here. Where do I teach at? I teach at a couple community colleges out here in the Chicagoland area. So that's where I teach, my friend. Well, yeah, but anybody is welcome in here, Prime. Anybody is welcome in here. You know, it may be like that, but you know what? Anybody who wants to learn or anybody who wants to, just have a nice time, you're more than welcome to join at any time when I'm online. So at any point you can join and hopefully you learn something that hopefully will be helpful to you. We're here to learn, so that's what we're here to do, and have some fun along the way. The fun part too. The fun part. But I like broadcasting here on Twitch because it's a lot easier than so. Zoom smells. That's what I think. All right. But that is the end of our class here for today. I want to thank everybody who came out here to the stream once again. You guys are absolutely 1000% fantastic. Thank you very much. I really appreciate everybody's time. Again, get that homework done, get that test done if you haven't done so. Make sure you get that stuff done. Otherwise, I hope everyone has an absolutely fantastic weekend. And we are going to be back here, same time, same place on Tuesday, okay? Tuesday at 6 o'clock. We'll be right back here doing the next section here in Chapter 5, okay? So in Chapter 5, we're going to keep on moving along here in this section. That's what we'll be doing here for next time. All right? All right. I hope everybody has a great weekend. And again, if you need to contact me, you can contact me here via Discord or my email. You guys know exactly where to find me. It shouldn't be too hard, I promise. So if you have questions, feel free to contact me. All right. Have a great weekend, Anna. Have a great weekend, everybody. All right. Take care of yourselves, and we will see you next time. All right. Take care, everybody. And as always, everybody, as always, stay safe, stay healthy, but most importantly, stay sane. All right. Have a great one, and we will see you all later. Take care, everyone. Have a great weekend. See you later. Bye. No, thank you, Strolling. Thank you. Take care, my friend.